Well, since yesterday was Christmas and I've got a bad green screen, which is why you see all this stuff over me. It's not even a green screen, it's just a piece of fabric that I've hung up with some zip pulls, which we use in construction for painting and dust control. But the question today is, what are all these graphs behind me and what do they have in common with this and this? Well, one of those Richard Rawling likes and one of those I like. The bottom line is cans. We all know this. Aluminum cans are a great example of a house. In the summer, an aluminum can condensates. So do a lot of our drinks. So do our water cups. They condensate because of a temperature differential. This chart, this chart right here kind of shows all that difference of temperature based on the humidity that's in the air and where the dew point or condensation point is. And there's an easy way to solve this in the summer. We just take our can that's cold and it's warm outside and we put a koozie on it and now it's fixed. You know what? We can do the same thing with this can. It's cold, we put a koozie on it, boom, it's fixed. It's not going to condensate. Well, that's what this chart's showing. As houses go through different temperature ranges on the inside to the outside, there's different points at which the house can condensate. And the key to all this is, and why we're talking about it here in the middle of winter, is your house is warm inside. Maybe 70, 75, depending on how you like it. Some people out there are crazy and like it 65. Those people, I adore you. 65 is great. The outside temperature is a dry air because it's cold. Cold air can't keep as much humidity as warm air. So what happens is the house can condensate from the outside in. And so you have condensation forming at different points outside of the house. And a lot of condensation over time leads to rot and problems. The house isn't the only place on the outside this can happen. This happens in showers. Your shower is a warm environment, 100, 110. The outside environment, depending on what you keep temperature, is a cold environment. Also another potential point of condensation. You can see on this chart over here, this talks again about humidity, and it talks about the dew point, which is similar to humidity, and how insulation affects the rate of condensation. That goes back again to our can in the koozie or our water in the koozie. And what we want to do in houses is eliminate that condensation. Now, I know another thing you're not thinking about on this can. If you look at it, this can is sealed. This sealed can would be a great thing to think of as a blower door test on a house or air changes per hour. The lower the air changes per hour, the tighter a house is. The tighter a house is, the less it leaks. A leaking house can form condensation in lots of places. So what you like to see, and you see a lot more with the building science, is they're putting, or building engineering, they're putting insulation on the outside of walls and roofs so that the condensation doesn't happen inside your walls where you can't see it and there's a lot of damage. Now, the reason a tight house or low air change per hour house becomes very important is because let's say you have a hose bib and it leaks around that hose bib. Well, now you have another dew point or a point of condensation that can collect. So much like the can, you want a very tight house and a very sealed house, because a sealed house keeps bugs out. It keeps your air that you're paying for in, and those benefits over a long period of time on a house are great. You don't want a house, it's not a short-term investment. A lot of people keep their houses short, maybe 5 years, maybe 10 years. The house, though, is going to be there 50 years, 100 years maybe. You don't want the house to fall apart because repairing a house is expensive. So much like the can and the condensation in the summer, you really want to look for points that you see dew points. You can see it a lot on roofs right now. If the weather's right, you can see kind of a frost forming on the roof and you can see the roof rafters. That's a condensation point in the house. And it happens behind your walls, it happens on your roof. And really, if you're looking to buy a house, which we help with, and this is one of the things that's hard to see, but we can see some outwardly signs on brick and things that we point out and say that might be a problem now or it might be a problem in the future to help homeowners make a good decision. So my takeaway from this for y'all is when you're going to buy a house, look for that. When you're building a house, ask your builders or your project manager, whoever, how they're going to manage water management, air management, condensation management, because that house is an investment, and an investment is only good as the sum of the parts. So I hope you guys all had a Merry Christmas and a Happy New Year. Thank you.